Hello everyone, welcome to Microsoft Build 2017 and our session where we showcase how Windows apps developers can step outside the boundaries of app containers and gain privileged access to hardware using custom capabilities. My name is Viraf Gandhi and I'm a program manager with Microsoft's Windows Devices group. Joining me today is Ben McGregor, who's a software developer in the same group. So Ben, let's kick off by telling our viewers more about hardware app ecosystem today.
Definitely. So we understand that many of our OEM and IHV partners have valuable hardware apps that customers can use to configure system settings, device settings, or perhaps just get system information when the customer needs to contact support. We also know that these apps are oftentimes written in Win32 for classic desktop, and because of that, they can't take full advantage of what UWP apps provide.
So Ben, our viewers might be wondering why more Win32 apps aren't UWP already?
Well, there have been a number of gaps in bringing these hardware apps to UWP apps, and one of those big gaps has been the ability to access privileged system software like NT services and drivers. And that's what we've been working on for the Creators Update to Windows 10, and what we're going to talk about today. But I guess there's a bigger question of what benefits do UWP apps give our partners anyway?
So in order to better understand this, let's go through our journey of Windows 10. So Windows 10 has been built from the ground up to support the same OS experience across a multitude of devices and form factors. At the heart of Windows 10 is a core OS that includes the Universal App Platform. It exposes a common set of APIs that allows UWP apps to run on any Windows 10 device family. A common set of development tools make it really easy for UWP app developers to write these apps. These tools have been incorporated into Microsoft Visual Studio that is being used by hundreds of thousands of developers across the world. UWP apps are declarative. They have isolated impacts, so they do not affect other system state. They can be independently serviced via the store. And most importantly, UWP apps are built with the notion of building once and running everywhere across the entire Windows 10 device family. So Ben, you worked on Windows Store device apps, also called as WSDAs, during Windows 8 days. Some of our viewers might be familiar with those apps. Why didn't these apps meet our developers' needs?
Sure, let's talk about that. So in Windows 8, we built a model called Windows Store Device Apps, and that was trying to also bring some of these hardware apps into the Windows Store. But this predates the Universal Windows Platform, and because of that, these apps only work on Windows Desktop. So we needed a different solution. Also, these WSDA apps also couldn't access NT services directly, only drivers. And the device metadata that was used to allow the apps to access the drivers is also complicated, and our partners really just wanted something better.
So I think with Windows 10 Creator Update, we set out to design a way for UWP apps to be able to easily and securely gain access to system software such as drivers and NT services without really going through the authoring complexity that device metadata brings forward. This functionality also aligns with Microsoft's long-term goal of enabling a richer hardware-driven universal app ecosystem and make it available to all the Windows 10 device form factors. The way we've enabled this in the Creators Update is by introducing custom capabilities. They are very similar to app capabilities that are already available, and UWP apps use it every day. Custom capabilities allows the capability owner, who is also the owner of the system resource, like the driver or the NT service, to securely grant access for its use to any number of UWP apps. Like other app capabilities, custom capability also needs to be defined in the app manifest prior to its use.
So here's a quick example of what it looks like in your app manifest. You put the custom capability in the capability section just like you would any other capability. Its element name is custom capability, and the name is a string just like any other capability. Now there's one other small piece, but we'll talk about that later.
Okay, let's dive a little bit more into custom capabilities. So the driver or NT service author exposes a custom capability that can be used by UWP apps that are granted access to it. Access to NT services has been enabled using the very familiar RPC protocol. So prior to Windows 10 Creators Update, RPC was off limits to UWP apps, but custom capability essentially unblocks that access. Driver access is enabled from UWP using custom capability and the familiar windows.devices.custom WinRT API. So Ben, can you explain to our viewers in detail how they can enable access to NT services and drivers by using custom capabilities?
Sure. Let's take a look more closely at this slide. So let's assume you're a driver developer and you want to open your driver up to certain UWP apps to open the handle directly. So the way we've enabled that is you're going to set a property on your PNP device interface object. That property is simply a string list that lists each custom capability that you want to grant access. You can do this in one of two ways. The first way is through your INF file. You simply add an interfaces section, add the interface that you want to grant access to the custom capability, and then put a property, and under the property section, put this custom capability property. The other method is you go to your driver code directly, and you're going to call WDF device assign interface property, and you're going to set the same property. Now, once you've done this, any UWP app with that custom capability will now have access to directly open a handle to your driver. Okay, let's move over to NT service now. So let's assume you have an NT service and you want to grant access to UWP apps. The way you're going to do that is, as Raf mentioned, through the RPC APIs. Now, what we did in the Creators Update is we just opened up many of those RPC APIs, and we also created a new API you can call to convert a custom capability from its name into a security identifier. That's called derive capability SIDs from name. So as you see here, we have some distilled version of code we're going to show you later, which basically you have the custom capability, you derive capability SIDs from name, you use that SID to build a security descriptor, and then you're just going to set it on your RPC endpoint and then on your interface. Now, any UWP app with that custom capability can open your RPC endpoint.
So this is great. So once a developer opens access to their service or their driver, can any UWP app access it?
Well, no, or that would defeat the whole purpose, thankfully. So the way this works is once you've declared that custom capability in your app manifest, your app can no longer install unless you have a file that authorizes your app's use of that capability. So the way we do that is by this embedded file inside your AppX package we call assigned custom capability descriptor file. Now it sounds complicated, but you can see here that the code is under 15 lines of XML. This file would be provided by the owner of the custom capability, and then it has three sections in it, which let's go into a little more. So the first section you'll see is called capabilities, custom capabilities, sorry. And this lists all the custom capabilities that the SCCD file is vouching for. The second section is authorized entities, or think of it as apps. So this says which apps are allowed to use this previously mentioned capability. The app is identified by a package family name and by the certificate signature hash for which the app will be signed with. The final section is called catalog, and this is the catalog signature of the SCCD file itself. And this will be provided by Microsoft on behalf of the custom capability owner, and this ensures that the SCCD file can't be tampered with.
That's great. So up until now, we've introduced custom capabilities. We've also shown how a driver or an NT service can expose that to a UWP app or an authorized UWP app for that matter using the SCCD file. Now is a good time to walk through the high-level app development process. So app developers request access to custom capability driver or an NT service from a capability owner. So the capability owner is responsible for vetting the app developer and making sure that he is the person who the app developer says they are. And once the vetting is completed, the app developer will grant access using the SCCD file that you just talked about earlier. App developer then bundles the SCCD file with his or her AppX and then packages it and publishes it to the store. Pretty straightforward. When the app is downloaded from the Windows Store, the OS checks for a few things. Firstly, it ensures that there is a signed SCCD for every custom capability that's listed in the app manifest. Second, the SCCD is not being tampered. That's another check that happens as part of the install process. And third, it makes sure that the SCCD lists an app that is authorized to use that particular capability. Once all these checks are passed, the OS installs the app, and the app is granted access to that particular system resource. So I think we've talked about the high-level process, shown you code snippets. Now is a good time for us to fire up Visual Studio and demo everything and tie everything up together.
All right. Well, let's switch over and look at Visual Studio. So I have Visual Studio 2017 here, and I've opened a project called Custom Capability, and this is actually available on GitHub, so you can go check it out yourself as well. It has 3 projects in it. The first one is the UWP app itself. The second is the RPC interface, and the third one is the RPC server. So let's pretend this is like an OEM welcome app that an OEM needs to tweak some system settings after the user logs in the first time with their brand new system. So we have an RPC service that's going to do this work, and so we're setting up an RPC server. So we can go to the RPC server code, and we'll see here at the top we've defined the custom capability that we've gone to Microsoft and gotten from Microsoft. And now we want to open up our RPC server with that custom capability. So down here in our start routine for our RPC server, we're going to get the capability SID. Next, we're going to build up our security descriptor, granting generic all access to that capability SID. Finally, we're going to use that security descriptor when we register the endpoint for RPC. And then right after that, we're going to use it again when we register the interface. Let's get that RPC server running. So I've already built the project, and I'm at the output folder of the project. I'm just going to start the RPC server in console mode, though it could be started in service mode as well. Now that service is running. So let's go back and take a look at the app. Let's open the package manifest and scroll down to the capabilities section. Now, first I'm going to run the app without any custom capability defined, and you can see that by default the app's going to get access denied when it tries to use that RPC endpoint. But real quick before we go into that, I want to mention this sample we provide on GitHub shows also how to access a driver directly as well, and that's these other 4 scenarios here. The first scenario we're going to look at is just about connecting to an NT service. So the RPC server and this app are essentially just going to do some read-writes just as a proof of concept. So we're going to hit start, and we'll see down here we got error 5, which is access denied. So let's go back to our app and declare that custom capability that should grant us access to that RPC server. So we're going to uncomment the code and hit F5 again. So we'll just wait a second for it to start. Now, if you think back, there was one other step that's missing. And that is, making sure it showed the right thing. So we see that the deployment failed with file not found. This is what we'd expect because as the app's installing, it's looking for that SCCD file, and it didn't exist. So let's go ahead and add the SCCD file that authorizes access to that custom capability. So we're going to go to Add Files for the project, Add Existing Item. So let's pretend we've just gotten the SCCD file from our partner that owns that. We're going to go ahead and add it to the project here. There's one other important step you need. Once you've added the file to the project, it's not enough to get included in your Apex package. So to do that, you need to right-click, go to Properties. You'll see this option here that says Content. We need content to be yes, which means we do want that file included when we build the Apex package. Let's take a quick look at the SCCD file. You'll see it declares that custom capability. And it also is granting access to our package. This is the package family name of this sample. I also want to mention, you may be wondering, why do I have to get this SCCD file from my partner before I can start coding? Well, we do have one exception, which is if you're on the desktop build of Windows and you're in developer mode, we don't actually require the catalog signature for the SCCD file, and we also don't require this to be the actual signature the app will be signed with. So our machine is actually in developer mode right now, and we're on desktop, so therefore we're okay to not have a valid signature. But now that we have this SCCD file in our package when we build, it should automatically work here. So we're hitting F5 again. It's building, deploying, running, and we should see that we are able to successfully connect, and there it's doing read writes from the RPC server. And that's the end of the demo.
Excellent. Thanks a lot, Ben. So let's do a quick recap of today's sessions. So Windows 10 Creator Update introduces custom capability, which is a new type of Windows capability that allows capability owners to grant secure access to a driver or an NT service to any number of UWP apps. The benefit of this model is that it is flexible because IHV is in control of which app has access to their driver or NT service. It is secure because the integrity of the authorized users, which is the apps, is verified at install. So this essentially disallows unauthorized sideload scenarios. And last but most importantly, since this is a UWP app, it is designed from the ground up to work across all Windows 10 family of devices.
So we have some materials available for you. So if you, as we mentioned before, you can go to GitHub and get that UWP app sample that we just showed. You'll also find with the WDK, we have updated the OSRFX2 driver sample to also show how to grant access to it using a custom capability. And finally, we have a getting started guide that will walk you through how, as a custom capability owner, you can grant access to your partners and how app developers can also use custom capabilities. So go check those out if you want to dig deeper.
All right, at this point, I want to thank our audience and viewers for joining us today in this session. It was great presenting custom capabilities and how apps can gain secure access to drivers or NT services to you. If you have any questions, please feel free to engage with us on MSDN in the future.
All right. Thank you.